So in example number 2, we're going to be talking about a word problem that doesn't have a provided diagram. So we've got a 4-meter flagpole that is not standing up straight. So let's make a diagram here. We've got the ground and we've got a flagpole that is leaning. So here's our flag and it's leaning a little bit. There's a wire attached to the top of the post and it's anchored to the ground. So here we go. We've got a anchored right here and it's up to the top of the post. The wire is 4.17 meters long. So when you're given questions that don't have a diagram, it's your job to make a clearly labeled diagram. That's part of the solution. The wire makes a 68-degree angle with the ground. So here is the ground and here's the wire. So this angle is 68 degrees. What angle does the flagpole have with the wire? So here's the flagpole and the wire, so that means I'm looking for this angle right here. So let's call that angle B. And I'm going to call this A and this C. So your labeling can be, it doesn't matter as long as you label it on your diagram and then use that in your solution. So that means this side here is little a, this is little b, and this is little c. Now, there's one piece of information I haven't put on yet, and that's the 4-meter flagpole. So we know that C is 4 meters. So the question is find angle B. And I do not have a right angle triangle, so that means I need to use the sine law or the cosine law. I have an angle and its opposite side, so I'm going to be using the sine law. So the sine of 68 degrees over 4 is going to equal the sine of B, which is my unknown angle, over little b. But wait a minute, I don't know what either of these are, so that doesn't help. That means that B, I can't find out what B is right away. I've actually got to set up the ratio to find angle A first. So let's find angle A first. So then we're set up the ratio again. Sine of 68 degrees over 4 equals angle sine of A over 4.17. So multiplying both sides by 4.17, I have 4.17 sine of 68 degrees over 4 equals the sine of A. And if I take the inverse sine of both sides, you're probably pretty good at that by now. I get angle A, which means angle A is 75.15 degrees. So I'm going to place that in here, 75.15 degrees. And that makes sense because the way I've drawn my diagram, it's less than 90. Now the next step is to find angle B, and angle B they have to equal 180 degrees. So angle B equals 180 degrees minus 68 degrees minus 75.15 degrees, which equals 36.85 degrees. So we've now got an answer for what the angle is between the post and the wire. So is the answer reasonable? So I'm just going to do a quick sketch again of what we had found. Here's the flagpole. Here's the wire, 4.17. This was 4 meters. This was 68 degrees. This was approximately 75 degrees. And this was approximately 36 degrees. Those are just rounded in this case. Now, are those reasonable? Number one, this one was reasonable because we said, oh yeah, it's just a little bit smaller than 90 degrees, so that makes sense. And this is also less than 90, so, and 36 degrees is less than 90. So those are just two ways to check to see if your answer is reasonable, using a good diagram to help you do that. Now the bigger question is, what assumptions are you making with your solution? Well, I leaned the flagpole to the right. It could have actually be leaning to the left. So I could have made my flagpole like this, and that means that the diagram would have looked like this here. This would have still been 68 degrees. This would have been 4.17 meters. This would have been 4 meters. And this angle here, angle B, or right here, is completely different than the 75. So the assumption I was making was the direction of the flagpole. So I made an assumption with the direction the flagpole was tipping. In order to get this solution, it's the ambiguous case of the sine law, because notice here, this is the original piece of information, the three pieces. That is angle, side, side. So this is a clear indication that there might be a second option, that the angle is not in between the two sides, and I would have to, when I found the 75 degrees, I would have had to find the other option for that one using the ambiguous method we've talked about in the last lesson. So that's how you would do it mathematically. The other assumptions I'm making is that the ground is level, and the flagpole is straight.